Welcome to the Making Math Count Enrichment Camp at Saunders Middle School in Prince William County, Virginia. NASA Connect asked us to show you how to make and build your own wind tunnel and use it to test certain shapes for drag. Drag is one of the 4 forces that aeronautic engineers consider when they design airplanes. The other 3 forces are lift, weight, and thrust. Under the guidance of our teachers, Mr. Bill White, Miss Melinda Spencer, and Miss Trindle Miller, we will go through the steps you'll use in constructing your wind tunnel. Before you begin, go to this website to learn about wind tunnels. This will give you a good understanding about the measurement tool you're about to build.
After you've gotten your materials together, we begin by measuring the fan. Next, write the dimensions of the fan on the board. Each student should fill out the data sheet by determining the dimensions for the 8 trapezoid-shaped panels of the upper and lower sections of the wind tunnel and the 4 smaller rectangular panels of the test chamber. If the side of the fan is X, then the height and bottom width of the trapezoid shapes would be the same size and the top would be 1/3 of X, or X over 3. The dimensions of the test chamber panels would be X over 2 for the height and X over 3 for the top and bottom. After checking the accuracy of the calculations, the teacher will divide the class into 4 teams.
Team 1, 2, and 3 will measure and mark their panels. The teacher will then cut the panels. The test chamber will fit between the upper and lower deflectors, so it is very important that the measuring and cutting is accurate, so the parts will fit together and be airtight. Team 1 will cut a window in one of the panels and tape a piece of transparency film over it from inside. Team 2 will cut a window in one of its panels and tape a piece of transparency film over it from the inside also. Now carefully tape the sections together, making sure that the windows are on the same side. When the wind tunnel is assembled, tape it to the box fan so then the air blows out of the bottom. Place the wind tunnel and fan onto 2 chairs like this. Make sure the chairs block as little airflow as possible.
To make the drag force test gauge, Team 4 cuts a 10 centimeter by 10 centimeter square card. Next, punch a 1 millimeter hole 3 centimeters from the top center of the card. Remove the elastic from inside the party hat and measure a 15 centimeter long piece. Do not stretch elastic when measuring. Double it over to form a loop. Thread the 2 loose ends through the hole in the card and tape them in place. Next, mark the center of the card. Beginning at the center point, draw a solid line to the right edge. Using 2 millimeter intervals, draw 5 lines above and below the center line that was just drawn. Using cardstock, cut an equilateral triangle with each side 2 centimeters in length. Cut 2 small slits in one side of the triangle and place an elastic through the slit, centering the measurement point of the triangle on the center line.
While teams 1 through 4 are completing their assignments, use the templates to build the 4 polyhedrons: tetrahedron, pyramid, cube, and cone. Cut the shapes out, then bend along the dotted lines. Carefully tape the edges together to form the shapes. Tape string to the designated point on each shape. When the shape is suspended in the wind tunnel, it should be visible in the center of the test chamber. Now you are ready for testing. Before turning on the fan, note the position of the gauge. Start the fan on low speed. Count how many lines the gauge moves. Now increase the fan speed to medium. Count how many lines the gauge moves from its rest position. Do the same for high speed. The number of lines the gauge moves indicates the drag force exerted by the wind on the object. Run tests on the other polyhedrons. Record your results on the student data sheet. Now calculate the mean, median, and mode for each polyhedron at each speed. Using your results, make a graph. This will help you compare the drag force of each of the shapes. When all the data is collected and graphed, you are now ready to analyze the results.
Data analysis is one of the most important parts of an experiment. You know, this would be a great time for you to stop the video, use your thinker, and consider the following. Which factor, shape, mass, wind speed, or drag, is considered the constant? That means which of those factors stays the same throughout the entire experiment? And why is it important for this factor to remain constant? Look at your data. What relationship can you see between the shape of the object and the drag that's created? More questions like these and their answers can be found in the Educator's Guide. Teachers, you can download this from our NASA Connect website.